Hello everyone, Sir Leon here, and welcome back to another video in which we will be covering some key mathematical concepts that will help you to be better prepared for your exam. So let's head straight into this video. So the last time we looked at the laws of indices, we touched on the first two laws, in which the first law that dealt with when multiplying bases and multiplying terms, and then the next one dealt with when dividing. So let's look at two quick examples to recap. So let's say we had 3x to the second multiplied by 2x to the third. So the first thing to do is to multiply the number. So 3 times 2 would give you 6. And then the bases are the same. So we put back the base and we add the indices. 2 plus 3, which will give you 5. So the next one we had 10a raised to the 6th power, all divided by 5a to the third power. So once again, we divide the numbers, but because we're dividing, 10 divided by 5 would give you 2. And then we divide the variables as well. So the bases are the same. So we write back the base and we subtract the indices. So 6 subtract 3 would give you 3. And that is what we looked at the last time. So let's pick up from that. So let's look at the next law. So the next law says when there is a power outside of the bracket, multiply the power outside the bracket by all the powers in the bracket. So what this law is basically saying, if we have, let's say we have a raised to the third, all multiplied by, so let's say we have a raised to the third, all raised to the fourth power. This law is saying that this small number outside will multiply the powers inside the bracket. So this will be simplified to a 3 times 4 would give us 12. So this is what this law is saying. So let's say we had another example. Let's say we had 3x to the fourth, all raised to the second power. So the law says the power outside the bracket is multiplied by all the powers in the bracket, not just one power, all the powers. So this 2 has to multiply all the powers in the bracket. So we know we see a power here, but also this 3 is being raised to a power. So this 3 is being raised to the fourth power. So this 2 has to multiply the 1 and the 4. So this will become 3 raised to the 1 times 2 will give you 2. And then x raised to the 4 times 2 would give you 8. 3 raised to the second power, x raised to the 8th power. This can be simplified too. So 3 raised to the second power, that is like 3 times 3, which will give us 9. So 9x raised to the 8th power. And that is how you simplify that. Now there's 3x to the fourth, all raised to the second power. We can also think about the other law that we did previously and simplify it using that same law. So let's see if we get the same answer. So we know when something is raised to the second power, that is saying that whatever is raised to the second power is multiplying by itself 2 times. So 3x raised to the fourth power, all raised to the second power is the same as saying 3x to the fourth multiplied by 3x to the fourth. So, of course, we multiply the numbers first. 3 times 3 would give us 9. And then x to the fourth times x to the fourth, the bases are the same. So we put back the base and we add the powers. 4 plus 4 would give you 8. So 9x raised to the 8th power. And that is what this law is all about. So let's look at the next law. So this next law is pretty straightforward. It says the base remains the same when it is raised to the power of 1 or an index of 1. So this is basically saying 5 raised to the power of 1 is the same as 5. And we kind of discovered this as we were working through the other example. And also x raised to the power of 1 is the same as x. So any base that is raised to the power of 1 is the same thing. So this is also saying in reverse, if you don't see a power, that means that base is raised to the power of 1. And we kind of discovered this while we were working through the examples. And that's the beauty about mathematics. So let's look at the next law. The next law says, any base raised to the power of 0 is equal to 1. So the key thing is, any base raised to the power of 0 is 1. So let's say we have a raised to the 0 power. That will be simplified to 1. Now there's a long proof to show why this is true, but for now, we'll just focus on using this as a law, something that was proven, so we don't have to know the long proof. But any base raised to the power of 0 is 1. So, but we have to be careful with this law. So let's say we had an example, 2x raised to the power of 0. Now, what is being raised to the power of 0? Many persons may run and go and put, oh, the answer is 1. No, we have to be careful. You have to remember it's any base raised to the power of 0. So this 2x raised to the power of 0, this is the same as the 2 is multiplying the x. So this is like you have 2 multiplied by x to the 0th power. Now, x is being raised to the power of 0, not the 2x. So x will be equal to 1 because that is being raised to the power of 0. So this will be 2 multiplied by, now this will simplify to 1. So 2 times 1 will give you 2. So 2x raised to the power of 0 will be equal to 2. So don't be carried away and say, oh, the 2x is raised to the power of 0, so it's 1. The x is being raised to the power of 0, not the 2x. So it's any base raised to the power of 0 is equal to 1. And in this case, the base that was being raised to the power of 0 is x. So let's look at another example. So let's say we had 2x all raised to the power of 0. So in this case now, we see the base. Remember, the base is the thing that is being raised to the power. So in this case, we see the base will be 2x because it's the entire 2x in the bracket is being raised to the power of 0. So in this case now, this will be equal to 1 because the entire thing is being raised to the power of 0. And this is far different from 2x raised to the power of 0 as compared to 2x in bracket raised to the power of 0. So just be careful when you're looking at this law. So the next law says, when a base is raised to a fractional index, the denominator is the root and the numerator is the index. So let's say we had 64 all raised to the 2 over 3 power. So this is saying the numerator is the index and the denominator is the root. So we can rewrite this as the square root. We put a square root sign and this number here will go here. And then we put back the 64 and it will be raised to the 2nd power. And we can punch this in our calculator and this will give us an answer of 16. But the thing is, we can also punch in our calculator 64 raised to the 2 over 3 power. And then we'll get the same answer as 16. So either one will work. But this is what this law is saying. The denominator is goes in the root part and the numerator is the power. So let's look at another one. 100 raised to the half power. This is the same as the square root of, remember, whatever is the denominator will go here and the 100 will go back here and that is being raised to the 4th power. And it's like taking the square root of 100, which will just give you 10. So for the fractional power, if they ask you to simplify it, or if you don't have a calculator and want to work it out, the denominator will go in this part and the numerator will go at the power. And this is all there is to this law. So sometimes you may be asked a question, let's say you have the question 30 square root, let's say you have 3 and 2. And you ask to represent this as a fractional index, let's just say. You should know that the number outside here, that would be the denominator. So this will be the same as 30. So the denominator would be 3 and the numerator will be the number that is raised to the power. So 30 raised to the 2 over 3 power if you had to go in reverse. And that is all there is to this law. Let's look at the next law. The next law talks about the negative index. Now, the thing about a negative index, it's hard to interpret. If I tell you 2 raised to the negative 3 power, what does that mean? It's hard to understand what a negative index means, so we don't like it. So what we try to do whenever you see a negative index, you get rid of the negative index. You try to turn it into a positive somehow, because we don't like negative indices. So this law says when the base is raised to a negative index, it can be expressed as a reciprocal where the index will turn positive. Now, reciprocal is a big word. What does reciprocal mean? Now, reciprocal means, let's say you had the fraction 2 over 3, and we wanted to find the reciprocal of this. This simply saying you flip the fraction, and that is the answer. So the reciprocal of 2 over 3 is 3 over 2. Let's say we had the number 5. I want to find the reciprocal of 5. Can we flip 5? Yes. We know 5 is the same as 5 over 1. So the reciprocal of 5 over 1 would be 1 over 5. So if we want to turn a negative index to a positive index, we just flip the fraction, or we flip the number. Whatever's at the top will go to the bottom, whatever's at the bottom will go to the top. So let's look at some examples now that we have an idea what reciprocal means. So first example says, let's say we had 3 raised to the negative 2 power. Now, we are asked to simplify this. So what we need to do, we need to flip the 3, because the 3 is being raised to the negative power. Remember, it's whatever is being raised to the power, that is what you're flipping. So 3 raised to the negative 2 power, this will become 1 over 3. And now the negative power will turn a positive power. And 1 over 3 to the second power can be simplified as 1 over 3 to the second power is 3 times 3, which will give you 9. So 3 raised to the negative 2 power can be simplified to 1 over 9. So let's look at another example. 2x raised to the negative 3 power. So this is the thing. The entire 2x is not being raised to the negative 3 power. It's the x that is being raised to the negative 3 power. So we cannot rush into this thing and then say 1 over 2x positive 3. We cannot rush in and say that. That will be absolutely incorrect. We have to look at what is being raised to the negative power. So once again, we know that 2x is the same as 2 multiplied by x. And this x is being raised to the negative 3 power. So we can simplify this to being, if you want to get rid of the negative power here, this will be simplified and this will turn 2 multiplied by 1 over x to the third power. So we can simplify this forward and say 2 times 1 is 2 over x to the third power. And that is the answer. So we need to be careful. We cannot upturn the entire 2x, because the entire 2x is not being raised to the power of negative 3. It's the x that is being raised to the power of negative 3. So in future examples, we can simply skip all these steps. So let's say we had negative 5y raised to the negative 2 power. We can simply do this as negative 5 over y to the second power, because you already understand this piece. So it's just simply to upturn the thing that is being raised to the negative power. But let's look at this example. 3x all raised to the negative 2 power. Now in this case, as we can pick up a pattern from the previous example, in this case, the entire 3x is being raised to the negative power. So this will become 1 over 3x to the positive 2 power. But we're not done as yet. We see we can use the other law that we learned to simplify this even further. So 1 over 3x all raised to the second power. This will simplify to 1 over, now this is like if you have 3x multiplied by 3x, or we can use the law that talks about multiplying the powers in the bracket by the power outside the bracket. But for simplicity's sake, let's say we have 3 times 3 is 9. X times x will simply give us x to the second power. So 3x all raised to the negative 2 power will be simplified to 1 over 9x to the second power. So to conclude laws of indices, I'll put an example that combines more than 2 laws of indices. So let's see. So let's say we had negative 5x to the second power multiplied by negative 2x to the fifth power, all divided by 10x to the ninth power. So, of course, we see the first thing we have to do is simplify the top part first, because we always simplify the top part of the fraction. We always simplify the top, and if there's anything to simplify the bottom, we simplify those things first, and then we do our division. So we have negative 5x to the second power multiplied by negative 2x to the fifth power. Of course, we have to multiply the signs first. So a negative times a negative would give you a positive. And then we multiply the numbers. 5 times 2. 5 times 2 would give us 10. And x to the second multiplied by x to the fifth would be we put back the base, and 2 plus 5 would give us 7. And all of this will be divided by 10x to the ninth power. So now we have the laws of indices. Now we have the law in which we have to divide. So the first thing, of course, we divide the numbers. 10 divided by 10 would give us 1. So this will be 1. And x to the 7th divided by x to the 9th will be x to the 7th subtract 9. Now here's the thing, we have 1x, but in algebra we don't put back the 1. So it's okay to leave this as x. We understand that there's a 1 in front of that. So 7 subtract 9, this will give us x to the negative 2 power. 7 subtract 9 will give us negative 2. And we're done there. Absolutely not. We cannot finish this yet. We cannot leave this negative 2 as the power. That would be committing a mathematical sin to leave it as negative 2 power. So we have to turn that negative 2 power into a positive 2. And how do we do that? By using the law that deals with negative index. So this will be 1 over x to the positive 2 power. And that is how we can simplify this. We cannot leave it at this step. You will be leaving marks if you leave it at that step. Must take it a step further. So, and with that, it brings us to the end of our laws of indices. I trust that now you have a good understanding of laws of indices. These questions, when they come in CSEC, then most times they come fairly simple. They would most times look like these. So if you can work this here, you're on your way to doing very well in this question at CSEC. So ensure you tune in next time for our next video. Until then, take care.